Hello students, welcome back to this new session. In this session, we'll start with a new topic, that is linear equations of first order. Okay, they are also known as Lagrange's linear equations. So far we have learned the solution of homogeneous and non-homogeneous partial differential equations of higher order and first degree. Okay, that is linear equations of higher order, homogeneous and non-homogeneous. Direct solution by integration also we have seen, and also the solution of homogeneous linear differential equations, where we just considered how to solve it by considering it as an ordinary differential equation. Now let us learn and solve what is a Lagrange's linear equation. Okay, so let's see an equation of the form, an equation of the form P into P plus Q into Q is equal to R, where you know very well about this P and Q. Small p is dou z by dou x and small q is dou z by dou y, and this capital P, capital Q and R are the functions of x, y and z. Okay, so such an equation, it is called a linear partial differential equation of first order. Okay, or also it is known as Lagrange's linear equation. Okay, so now how to solve such an equation, and when do you arise such an equation, when this equation arises? This equation is obtained, such an equation, the equation of this form, I'll say the equation 1, I'll call this as equation 1, is obtained by eliminating the arbitrary functions from phi of u comma v is equal to 0, where u and v were the functions of x, y and z. I should say that u and v were or I should say are the functions of x, y and z, are the functions of x, y, z. Just before this session and before the solution of partial differential equations, we have also learned how to frame a partial differential equation, wherein we learned various methods by eliminating arbitrary constants and by eliminating arbitrary functions. One of the type was phi of uv is equal to 0. This type I have already explained. There are the session on this, it's there already. Please go back and check the videos on that. You have seen that any equation phi of uv, where u and v were the functions of x, y and z, we had eliminated this arbitrary function phi and had framed a PDE. Okay, so that PDE, the form of that PDE will be always of this pattern. Okay, that is P into P is plus Q into Q is equal to R. Okay, where this capital P, capital Q and capital R are the functions of x, y, z, and dou z by dou x and dou z by dou y will also appear there. Okay, you have seen it already. We had tried to eliminate dou phi by dou u, dou phi by dou v, is it not, by considering the partial derivatives of phi with respect to x and y, and then consider and all that, taking to the right hand side and simply dividing. You have seen the steps very well. You have seen how to solve this. Okay, so using all that background, since we get this PDE by eliminating an arbitrary constant like arbitrary function like this, we have to also learn how to solve the solution, how to get the solution of this form for this linear differential equation. Okay, so since let's see how to solve. I have written directly the steps for you here. To solve this linear equation, we need to follow about 3 steps here. Okay, so the first step is we consider the subsidiary equations. We need to solve this type of a linear differential equation, P into P plus Q into Q is equal to R. What's the first step we consider is we write the subsidiary equations for that. The subsidiary equations are dx divided by capital P, dx divided by capital P, that is the coefficient of small p present here. Okay, means the coefficient of dou z by dou x has to be written in the denominator of dx, equated to dy divided by q. Okay, the coefficient of dou z by dou y should be written in the denominator of dy, that is capital Q, and that is equal to dz divided by r. Okay, so that whatever is left behind, okay, after separating the coefficients of dou z by dou x and dou z by dou y, everything whatever is left you are going to shift it. Maybe the equation may not be in the standard form. What you have to do is you have to write this in the standard form and then separate all the terms on the right hand side. Okay, the remaining terms dz divided by r you are going to consider. Okay, now after writing all this, you can just see that you just can take two equations at a time. Say this is equal to this, now you can take two at a time. Yes, this is equal to this, or you can equate the first and the last one. Okay, taking two at a time you can solve them, and after solving you may get the solution. Say u is equal to some constant, v is equal to some another constant, is equal v is equal to b. Okay, so after getting this u and v, we write the complete solution as u is equal to f of v, or since u is equal to a is equal to f of b because v is equal to b. Okay, I hope this point is clear to all of you. With problems it will be still clear. Okay, let's continue with the problems and conclude this topic. So here is one problem for you. Solve y square z divided by x into small p plus x into z small q is equal to y square. Okay, so let's see how to solve this solution. Now first tell me what is capital P, capital Q and capital R. Okay, your capital P is the coefficient of small p, okay, that is y square z divided by x. Your capital Q is x into z, whereas your capital R is y square. The given equation is already in the standard form. I did not do anything. Okay, now once I get this, let us consider the subsidiary equations. Subsidiary equations, the first step. So the subsidiary equations are dx divided by capital P is equal to dy divided by capital Q, dz divided by capital R. So follow the steps now. So what do you get? Dx divided by, what is capital P? Y square x is y square z divided by x is equal to dy divided by x into z is equal to dz divided by y square. Okay, now first I will consider the first two terms. Okay, let's consider the first two and try to solve it. Okay, you see, if I consider the first two terms, consider dx divided by y square z divided by x is equal to dy divided by x into z. Okay, now cross multiply the terms. This implies, you can write this as x into z dx is equal to y square z divided by x into dy. Yes or no? Now z and z gets cancelled. This x comes to the left hand side. So this is as good as writing x square dx is equal to y square dy. You see z and z is getting cancelled. Okay, just see that. And the variables are nicely separated. Okay, now what I will do is, I will integrate throughout. On integrating, what do we get? Integration of the first term, integrating the complete term. Okay, so it is, what is integration of x square dx? It will be x cube by 3 is equal to y cube by 3 plus some constant k, arbitrary constant k I will say. Okay, now x cube minus y cube is equal to 3k you will get, taking the LCM and taking y cube to the right hand side. Now this 3k is any arbitrary constant for me, so I'll call it as some a, small a. I hope that point is clear. So the first part I've got x cube minus y cube is equal to some a. Okay, this is one part. Okay, now what we'll do is, we'll consider the first and the last one. Okay, you see you can separate the variables. If you consider the first, if you consider the second and the last one, can you separate the variables? No. Just see, consider the first and the last one. There is x and z and y square getting cancelled over here. So you can see by just verifying or seeing it clearly, you will get what is required. Okay, see here. I am consider the first and the last term. It is dx divided by y square z by x is equal to dz divided by y square. You see y square gets cancelled. You will have dx divided by x by z is equal to dz divided by 1. You can write it like this as well. Okay. Or dx is equal to z divided by x into z dz. Okay. I'll continue this over here. Please make a note. Okay. Now see, you can multiply that x over here. So x dx is equal to z dz you will get. Again integrating both the sides, integration of x into dx is x square by 2 is equal to integration of z square z dz is z square by 2 plus some another constant, say m I will say. Okay, arbitrary constant. Now x square minus z square is equal to 2m you will get, like how we did over here. Okay, now since 2m is any arbitrary constant, m is any arbitrary constant, 2 multiplied 2 is again a constant, so I'm going to call it as small b. So x square minus z square is equal to small b. Just see, we have got two solutions. One is this and the other is this. That's what I told you, taking two at a time, okay, or taking certain multipliers and simplifying them, those simultaneous equations, you can get one or two solutions, and yes, two solutions you will get. After that you have to solve the complete solution. What should be the complete solution? I told you the final step. The complete solution is a is equal to f of b. A is equal to f of b. Shall I write it over here now? The complete solution is, yes, the complete solution is a is equal to f of b, or what is a? It is x cube minus y cube is equal to the function of x square minus z square. This is the complete solution for this problem. I hope that point is clear to all of you. Okay, so at times you may get you may consider the first and the last, like how I did in the second step. Okay, then later first two. Okay, so you may get the solution as x square minus z square is equal to f of x cube minus y cube. That is also no problem. That is also proper only. Don't worry about it. Okay, so it depends on how you consider it anyway, but these terms x cube, y cube, x square, z square, that should not vary. It should be the correct one. Okay, their places may differ. Okay, I hope the point is clear to all of you, how to solve it taking two at a time. Okay, continue with one more problem of this type. Now let's see how to solve this problem. Mz minus ny into dou z by dou x plus nx minus Lz is equal to into dou z by dou y is equal to Ly minus mx. Okay, this is a linear differential equation, or I should say it's a Lagrange's linear differential equation. So let's see how to solve this solution. I'm directly writing the subsidiary equations. The subsidiary equations are dou z by dou x is nothing but small p. Small p coefficient is the capital P. Okay, so I'm writing capital P as mz minus ny. Capital Q is nx minus lz, and your r is ly minus mx. So first write this. Okay, then the subsidiary equations is dx divided by capital P, dy divided by capital Q, and dz divided by capital R. Or dx divided by capital P means mz minus ny is equal to dy divided by nx minus lz, and dz divided by ly minus mx. Now if you consider any two at a time, first two or the last two or the first and the last one, you cannot separate the variables and solve them. Okay, for that, what you see, if I just consider first two of the ratios or the next two of the ratios or the first and the last ratio, we are unable to simplify it or separate the variables from this type. Okay, so for this typical kind of problems, what we do is we use the multipliers and solve. Okay, so using for the first set, I will use the multipliers. Using the multipliers x, y and z. So what exactly I will do with this multiplier? I will divide and multiply by x for the first ratio, for the first fraction. Okay, y for the second fraction, z to the third fraction. I am dividing and multiplying both to the numerator. I mean, I will multiply the numerator with x, denominator with also with x. Similarly with y for the second fraction, with z for the third fraction. That is the meaning of multiplier. So let's see what we get. It will be x into dx divided by mxz minus nxy. Okay, the first term. Even if you take x common and cancel with the numerator, it will not be, means what, the original fraction is not altered by doing so. Okay, so again we are multiplying y to the second fraction. So nxy minus lzy. Okay, and that is equal to z dz divided by, we are dividing and multiplying by z here. So lyz minus mxz. You will get it like this. Now you also have learnt about one more property of ratio and fractions, saying that a by b, if it is equal to c by d, then always remember a plus, it is also equal to, each of this fraction will be equal to a plus c divided by b plus d. Okay, so I can give you an example for this. Say if I consider what is 1 divided by, okay, 25 divided by 100, it is also equal to 1 by 4, yes or no? Now what is 1 by 4? If I add the two, 26 divided by 104 you will get. Yes or no? What is 26 by 104? 26 ones are 26, 26 fours are. Yes or no? So each of them is equated to 1 by 4, is it not? So using this property of ratio and proportions, what I will do here is, I will, since each of the fractions I have equated, so it must be equal to the addition of all. Now since I have taken only 2 in example, you can continue it to as many as fractions you are equating. Since we have got 3 fractions over here, so if you add x dx plus y dy plus z dz will be divided by, again if you consider the denominator, look at the denominator here, it is getting cancelled. If you add up all of them, you get the denominator to be 0. Just see that. Okay, now each fraction of this is equated to 0. Okay, now I can consider either first or the last, anything. At the ultimate this, I will get x dx plus y dy plus z dz is equal to 0. See here, because this 0, if I multiply with this, it will be 0. Whether if I multiply this 0 with this, it will be 0. If I multiply with this and this, see whether you get 0 or so or no, because mxz minus mxz minus nyx plus nxy minus lzy plus lzy. So all terms are getting cancelled, you get 0 over here. That is why we choose the multipliers in that way, such a way that it should get cancelled. Okay, so you are taking this term, and if you multiply to any of the fractions, it will be 0, or you can say that this is equal to 0. Now you can simply take the integration. On integrating, 1 minute, on integrating we get, so if what is the integration of x dx, will be x square by 2 plus y square by 2 plus z square by 2 you will get, and that will be equal to say some arbitrary constant k. Okay, or x square plus y square plus z square is equal to 2k you can call, and that 2k I am going to call it as some arbitrary constant a. So this is my first solution. Okay, this is my first solution. Now I have to use another set of multipliers so that I can reduce this and simplify. Okay, for that I will use the arbitrary the multipliers. Now again I will use the multipliers. Using the multipliers, look at what set of multipliers you can use now. Okay, multipliers, I had used x, y and z already. Now try to take another set of multipliers here. So already z is there, y is there here, m and n is there. Okay, and here n is missing. Okay, here l is missing, here m is missing. Okay, so if I multiply l to the first, okay, m to the next, and to the last n, let's check that. Okay, let's check that. What do we get? So you will get lmz, I'm just checking whether we get 0 or no, minus nly. Okay, plus n, I'm multiplying m x minus lmz, see, plus lmz minus lmz. Okay, let's see the last one. We have to multiply this with n, so lyn plus lyn, and minus mnx. Yes, this and this all are getting cancelled. So I can use the multipliers L, M and N. Okay, so let's multiply the numerator and denominator with these respective multipliers and see like how we had done previously. So this is my first answer. Okay, first solution, I'll write it here so that I will not miss it. Okay, this is the first solution. Now to solve this, I am using the multipliers L, M and N. So using the multipliers, the next set of multipliers L, M and N, what do we get? Just see. I have to divide and multiply the numerator by L and denominator also by L. LMZ minus NLY is equal to M dy divided by MNX minus MLZ. Okay, now that is equal to NDZ divided by LNY minus MNX. Now since all three are equal, so I can add all three. So LDX plus MDY plus NDZ divided by, since we have seen already the denominator is turning 0. Now you can take the last one and equate to any of the fractions, it will be equated to 0, or you can consider LDX plus MDY plus NDZ is equal to 0. On integrating, okay, on integrating we get Lx plus My plus Nz is equal to some constant b directly. Okay, so I've got another solution. Already we have got one solution that is equal to a. Okay, x square plus y square plus z square is equal to a, and another solution, next solution is this. So now I have to write the complete solution as a is equal to f of b. What is a? X square plus y square plus z square is equal to f of b Lx plus my plus nz. Okay, this is the complete solution of this problem. If you do have any doubt, do ask me in my WhatsApp group. Okay, continue in my next session.